Good morning everybody, my name is Bryan Drummond and I'm going to tell you about my BEV project. I have some family here to support me. Okay, so what does BEV stand for? Well, it could stand for Battery Electric Vehicle, it could stand for Barina Electric Vehicle, but in my case it stands for Bryan's Electric. So moving on quickly. Okay, so the contents of the presentation, basically the aims of the project, the sources of information, very useful, car selection, design, construction, performance testing, monitoring, budget, and the conclusion. Okay, so the project aims, I wanted a small city-based car, 2 passengers only, low running costs, preferably 0 running costs, and you can do that if you're running off your solar cells on your roof. Able to hold at least 2 sets of golf clubs with buggies, green credentials, charge from 10 amp GPO, means you can go to your neighbours and borrow the power and all that stuff. Budget about $20,000. Okay, sources of information. The ATA, which is now Renew, which is now called Renew, they have an EV branch at Swinburne, very useful source of information. They meet once a month. The Australian Electric Vehicle Association, another good source. I notice they've got a stand here. EVELton.com. This has now got 5,500 cars worldwide. Write-ups on it. My car's there. Australia's got about 600 cars. You can search by type of engine, type of battery technology, or type of car. Very useful. EV Works, interesting. Western Australian company. They supplied all my technology, so it's all off-the-shelf stuff. Good guys to deal with. Zebra actually developed the controllers and the battery monitoring systems. And CarTech, who's a local VicRoads BAS engineer. To get your car certified, you have to employ a BAS engineer. Okay, car selection. Alright, so I wanted a small car, less than 1,000 kilos. I've got some lists of some cars. Needs to have a reasonable body and condition. 2-door hatch so that you can put the batteries in the back. Manual transmission, front wheel drive, pretty standard east-west engine. Now, this is a big one, no network electronic modules. Around about the year 2000, 2005, cars had all the electronic modules networked, so if you disconnected one, you got all these error codes. Because you can't get the source code, very difficult to have. So you need to go for a bit of an older car. Workshop available manual, very important. Haynes make a heap of manuals, $50 on the internet, tells you everything. Gives you 49 steps to take the engine out, and most importantly, it has electrical diagrams at the back so you can actually work out what's going on. It is a good idea to have a roadworthy car to start with and registered. It just makes the VicRoads certification process easy, because if it's not registered, you've got to go through another roadworthy. Your normal standard mechanic will not touch an electric car. Okay, so a couple of design decisions. First design decision, what type of battery? Well, you've got to go with lithium iron phosphate these days. They're half the weight and size of the old lead acids. I decided to go for 5,000 cycles, which gives me a design life of 15 years. So far the car's 2 years old and the batteries have shown no degradation at all. Cell sizes generally 90, 100, 120, there's a 140 now, 160, so you pick a kind of a modular amp hour size. So I picked 100. Basically, 100 amp hours gives you 100 kilometre range. If you want 160 kilometres, you would go 160 kilowatt range. So this is the battery here. They're called CAB, or basically cell batteries. That's an individual cell, gives out 3.2 volts. And you buy them from China, as most other things. Okay, 2 types of motors you can go for. You go for AC or DC, just like the pop group. DC technology, very proven, been around for about 100 years, series type motor. Has brushes, unfortunately, but you get 100,000 k's out of a set of brushes, which is probably more than I'll get out of the car. Cheapest, great torque at 0 speed, very simple control, basically like a big light dimmer, high temperature. AC technology, basically permanent magnet or induction type, no brushes, durable by at least a factor of 2 when I did this design, which was 3 years ago. That now has come down to about 1.5, so they're getting cheaper. You do need an external speed encoder and some cooling fans. Now, the big thing you get with this AC technology is you get regenerative braking. That extends your range quite dramatically, particularly if you live in the mountains area. More complex control, but a higher speed limit. The next car I build will use AC technology. Okay, now the next decision you've got to do is work out how you're going to interface the electric motor to your transmission. So I decided to go with the no clutch option. No clutch is good because it saves the flywheel weight and it's a much simpler adapter and coupling system to make. So basically it's an automatic. I just put it in the third gear and it goes from 0 to 110 k's. I use reverse to reverse the motor so I don't have to change direction electronically. You can change gears on the move, but you don't need to. For instance, if I use second gear, I take off, it just spins the wheel and sets the lights, blows smoke. Now, the only thing is, because it's a DC technology, there is no engine brake. When you take the car off, it's like just dropping it in neutral, you just keep rolling, so you do use the brakes a bit more. Brake pads are $40 a set, not a cost for it. As you can see down here, the main part is, this is the existing transmission. You've got this adapter plate which you need to be machined and custom to your car. That connects the transmission onto the electric motor, and then you've got a coupling. Now, a coupling basically uses the clutch plate, and the reason we use the clutch plate is it has 4 springs in it to give a little bit of misalignment ability, and also takes the shock out. Okay, how do you build it? Well, there is a vehicle standards bulletin number 14. This is the one that's recognised in Australia. It's a 20-page document, basically pretty simple. No structural mods. Brakes and steering will be operational, which you'd expect. Airbags will be operational and fitted. The electric motor continuous power has got to be less than 120 of the original ICE engine, the internal combustion engine. That's very easy to do because electric vehicle engines, for instance, mine's rated 22 kilowatts, but it peaks at 60, so it's a very easy thing to do. You need to have a dismister in Australia. That may change because I don't know, most of you realise the Australian currency shut down 12 months ago. There's a big upset about how we're going to design standards and that type of thing. That requirement may change. All high voltage wiring, which is greater than 60 volts, has got to be in orange, so when the rescuers come to cut you out of the car, they don't cut the wrong cables. Plenty of warning labels. Inertia cut-off switch to disconnect the battery in case of accident. It's a little $20 switch. And you've got to have a hardwired stop button. Again, pretty simple. And they do recommend installation monitoring from the HV supply to the car chassis. So the HV system is totally floating. It doesn't use the chassis for a turn. Okay, the next thing you've got to do is get down a VAS engineer. So this is the VicRoads system. There's 100 VAS engineers. Only 2 or 3 of them want to talk about electric cars. This guy from CarTech is particularly good. He's an ex-Holden engineer. So what you do with all consultants, the first thing you do is you engage them and you have a discussion up front before you even touch the car and tell them exactly what you do. We went through every clause of this specification and ticked off what we were doing. He wanted an extra low vacuum warning, dash warning light. That was one of his little criteria. He wouldn't allow me to put any equipment between the front bumper bar and the front of where the engine was, the old engine. That's because obviously the crumple zone has been designed for an internal combustion engine electric motor. So it's easy to do. So anyway, came out, pretty intense, 2-hour inspection, half-hour road test and inspection, and then what happens is this here is your actual plate, and in that I don't know whether you can see that it's actually been modified for the type of engine, which is electric, and also the seat capacity has gone from 5 down to 2. Okay, bit of construction details. Battery pack needs to be designed to take a 20G impact, i.e. 20 times the weight. The batteries weigh 160 kilos roughly, so that's a 3-ton design capacity. I used aluminium, 6mm welded together. Aluminium's cheap and also it's light. And I used the rear seat belt attachment points. You can see which are there and there. That's those 2 points there. So there's a total of 9 bolts to hold that down, and you use high tensile bolts, which are available at Bunnings, by the way, very cheap. Okay, a bit more detail. So this is the actual completed battery pack. I put a nice clear thing over it so you can see it. There's 45 batteries in series there. Each battery is monitored by this battery management little unit. It looks at the voltage, the under voltage, the over voltage, and the temperature, and if anything's out, it tells you. This unit also does what they call pack balancing. So it makes sure that the voltage across each battery is the same. And as you can see from this screen here, I've got them balanced within 0.01 of a volt, which is very good. Okay, a bit more construction details. This is an onboard 2 kilowatt charger, so this plugs into a 10-amp power point. The interesting thing about chargers these days, you don't tell it what voltage you want, you just tell them the battery technology and the number of cells, and they work it out for you, so you can't get it wrong. This is where you put in the liquid electricity. It's just in where the fuel filler goes. I try chargers, it takes 3 to 4 hours to charge it up. Okay, construction. These particular cars, you have to take the motor out underneath the car. You can't bring it up through the bonnet. So I had to, I got a horse from Bunnings with a chain block. The chain block was $50, the horse was $60. That supported the engine, and then I dropped it down. I had a car hoist, which made the job very easy, and I dropped the engine out. Interesting, you think you'd get some money for an engine, took it to the wreckers, they wanted to charge me to take it away. Ridiculous. Okay, now this is probably the hardest part of the project, is to get an adapter and coupling plate. The first attempt didn't go too well, the second attempt did it in 3 weeks, and a great job. So you need somebody who can do CAD design. As you can see, there is the clutch plate there. This is the adapter plate. It had to obviously allow for things like drive shafts and all that. It came up beautifully. This is the actual unit here. And as you can see, this is the old transmission, the adapter plate, and that's the electric motor. So the electric motor is relatively small. It's probably a third of the size of the equivalent petrol engine. This was a 1.5 litre 4-cylinder injected petrol engine. So that's it all there, ready to go up. Okay, so this is it up now, looking underneath the engine, underneath the car. So I've taken out the half shafts, which go to the left and right wheels. There was a tie rod suspension here that's taken out. As you can see, it's actually quite good access there. So it's just sitting there. I've already used 2 of the engine mounts, the one on the left and the one on the rear. I have to make up another one for the right hand side, and I'll show you that now. Okay, so that's looking down on the engine now. So you can see that I've put in a new extension here to hold the motor on this right hand side of the car, which goes into an existing engine mount. That's the existing left-hand mount which goes on the transmission, and that's the other transmission, the rear mount, which goes there. So that's it all sitting there nice and rugged. Okay, you have to add a few extra things. It's not just a matter of ripping out the petrol motor, you've got to put a lot of things back in. So I wanted a tacker on the car. This was a budget car, didn't have a tacker, so I put in a little counter and a display. Couldn't believe it, $16 including postage from China. Okay, so the other thing you need to do is you have your 12-volt battery to run your headlights and your radio and the iPod chargers and all that. So you need a converter to go from 144 to 12, so that's that unit there, it puts out the 70 amps. You don't have a manifold on the car, electric car, because you've lost the petrol engine, but you do have power brakes. So you need to put a vacuum pump in, which is there. So it's a vacuum pump, and it's got a couple of pressure switches to tell you if your vacuum's lost, which is one of the things that the VicRoads inspector wanted. This is the actual controller. It's basically just like a big light dimmer. It's smart, it's temperature controlled, it's also current controlled. It talks to the little display, which I'll show you later on. This is a little supervisor computer just to keep an eye on things, also when you charge and discharge. It does a couple of nice things. For instance, it makes your fuel gauge actually represent 0 to 100% state of charge. You need to have a contactor to actually turn the power off and some relays. All needs to be obviously in a waterproof box. Okay, so this is the end job now, and the car's out there, so you can come and have a look. Please ask your questions. So going through, this is the main control box in a nice IP65 enclosure. That's the converter from 144 to 12. This is the power steering, it's an electric power steering pump because I lost my mechanical power steering pump. That there is the vacuum pump. That's the main controller for the DC motor. This blue thing here is a bit of downpipe. That's to give you an accumulator for vacuum. Pretty easy to do. Bunnings, about $10 worth of parts. This little thing here is a hot water heater, and there's a little pump under that green bottle there, so that recirculates coolant around, so that's how I get my dismister to go, which means I just use the normal controls in the car. Yeah, that's pretty well it. As you can see, there's nothing between here and there. Oh, by the way, that's the throttle there, that goes back to the exonerator. Okay, this came off the internet, I modified it slightly, pretty simple. Anything in orange is basically 144 volts and needs to be labelled that way. Blue is communications cable, and the other stuff's all 12 volts. Pretty simple circuit really. If you can change your car battery and wire up simple things, it's pretty easy to do. Okay, weight reduction. We all need to reduce weight, and electric cars need to do it more. So for instance, the spare tyre weighs 15 kilograms. I took that out and I replaced it with 300 grams of this tyre full of thing. So the big thing is try and get the weight down as much as possible. The car accelerates better and you get longer range. Okay, performance testing. You need to take the car to a weigh bridge, get it certified before you start. So this is curb weight, so it's got to have a full tank of petrol, it's got to have a spare tyre, it's got to have a jack, anything in it. 920 kilos before, 1,000 kilos afterwards, so I gained 80 kilos, even though I obviously took a bit out. The batteries weigh 160 kilos to give you a bit of an idea. Test, I drove down to Frankston with my mate Rudo here as a test pilot. So we did 105 Ks with 7% left, so I call it a 100K range. That was 2/3 highway, 1/3 urban, and that's works out at 124 kilowatt hours per kilometre economy. That's actually quite a good number because it's a light car. In fact, it's probably 30 or 40% better than a Tesla, but the Tesla has a ton of batteries on it. So. Okay, so this is the monitoring system. Again, this is all proprietary stuff developed in Australia and Western Australia. This is your main screen, nice and simple. You just got a bar chart to tell you you've got 27% left in your batteries. You've got your voltage, your current. The nice one is the power. So it's interesting, like going along at 60 Ks on a flat road with no wind, the car only takes 4 or 5 kilowatts of power. Come to a hill, it goes up dramatically. Put your foot down, that'll go to 60. You also have the auxiliary voltage and the temperature of the motor. You can go to another screen, you can actually see what the motor control is doing, the percentage of throttle, a few other things. This is a summary of all the batteries. So there you'll see there's a difference between, Newman is 3.24, maximum that, so 0.03 of a volt, which means the pack's very well thing. Also the temperature. And the car, I recalibrated the fuel gauge to give me the same as this, so 0 to 100%, and also the temperature goes from 0 to 100 degrees. Again, that's independent mode. So nice and simple.
Right.
Bullshit. Okay, cut it off now. 60K, breakdown, 16K for materials, half for batteries, 4K for services, timing 6 months. Actual labour, 8 man weeks, 2 people useful when taking the engine in and out. Okay, conclusion, great second city car. Fuel cost is virtually zero, easy to enjoy, car is an automatic, very quiet, payback 7 to 8 years based on $1,500 of fuel and $1,000 of maintenance. Fun to do. And the last one, questions? I'll be out of the car.
Yeah, we grab